In this video, I just want to point out a couple of neat things that happen as we start to transform exponential functions. So I'm going to start with the generalized rule of an exponential function. Just this y equals 2x was the parent function that we talked about before, and we know that the general rule, what the general rule looks like, I'll show you that in a second. But I can also modify that in various ways. So whereas we know that the 2 here is the base or the common ratio, we can think of that as this b value here. And I could multiply that by some other starting value if I wanted to, some a value up front. I could also, if I wanted to, shift by adding a k value or maybe subtracting a k value, shift down, the entire curve by a vertical shift, a lot like we've seen with parabolas or absolute value functions. And then this shift will also govern the location of that horizontal asymptote. Okay? And I could, of course, change the horizontal aspect of the graph. I could by shifting it horizontally left and right. Okay, so each of these different values we can play around with a little bit, and then I'm going to come in and I'm going to play around with the base a little bit, and we'll just take a look at what that is. So I'm going to use Desmos to talk about some of these things. So let's just take a look at a Desmos graph that I set up. So here I've got a times base of 2 to the x minus h plus k, and I've got sliders built in for these different values, and I'll post this Desmos interactive along with the video so you can play around with it on your own. But if I start by setting k to 0 and h to 0 and just having a be the value of 1, you can see here we've got our parent function where I've just got y equals 2 to the x, right? That would just be our basic parent function. But as I start to play around with this k value, right, as it goes up above 0, notice that the entire graph shifts up and the horizontal asymptote, so for example, if I set k to 2, notice that this horizontal asymptote, the place that it's getting closer and closer and closer to without ever going over, is now the value of 2 instead of the value of 0. So let's set that back to 0. Just shifting h, you can see that this sort of moves that point, the point of the bend, that starting point, moves it sort of left and right. Okay, so I'll set that back to 0. And then let's take a look at what this a value does. So notice here I'm back to y equals 2 to the x power, right? So my asymptote is at 0. My starting value is at 0, 1, because 2 raised to the 0th power is 1. So let's change a to 2. So what do you notice now about that value on the y-intercept? So now when x is 0, notice that it's 2 to the 0th power is still 1, but because a is 2, it's 1 times 2. So that's moved this starting value, that's moved this point now 2 away from the asymptote instead of just 1 away from the asymptote. If I make a 4, now the y-intercept is 4 away from the asymptote. Okay. Be careful when you think about it a little bit because the horizontal shifts have an impact on that, but I'll let you play around with that a little bit more when you're looking at Desmos. Okay. One other thing I wanted to point out is what happens when this a becomes negative. So notice that in those instances, the entire graph inverts, and so now we're going exponentially negative. So we're going away into the negative realm at an exponential growth or exponential rate. Okay. So let's put this a, oh, and you might want to play around with some other values as you look. So let's put this a back to 1, and I want to just take a look at what happens when I change the base in a couple of ways. So notice I just changed the base from 2, from a whole number, to a fraction. So I know that this is an exponential decay value. And notice now what the graph is doing. It's coming down and it's getting closer and closer to the asymptote, as opposed to getting further and further away from the asymptote. Okay, so it's approaching the asymptote now. It's decaying toward the asymptote. Okay, and you can play around with some other values there to see what that would look like in different contexts. And another thing that you might want to do is play around with some other values. So, change those base values to 10 or to 1/10, right? And see sort of what they look like. Okay. So again, I will post this Desmos activity with it, and one of the best ways to get a sense of these exponential functions is to just graph a lot of them, and the sliders give you that opportunity to really play around with it and see what they're doing. Okay, I hope that helps. Thanks so much.